Hey everyone, welcome back to Cracking the GRE Math Subject Test, Calculus 1. This is our 50th problem. It's our last problem in our calculus section. And it's a tricky one. So this problem asks us to find this limit as x goes to 0. If you just plug in 0, you'll get 0 over 0, which is indeterminate. So one option is to use L'Hopital's rule, but it'll get kind of hairy when you take the derivatives of the numerator and the denominator. So another option is to look at the Taylor series expansions of the numerators and of the numerator and the of the numerator actually, and I'll show you what I mean. Remember that the expansion of e to the x is the sum. Oh, let's just write it out. It's easier that way. It's 1 plus x plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial, etc. Okay, and the Taylor series expansion for cosine is similar, but it's just the even terms and they alternate. So we're going to have even power terms. So we're going to have 1 minus x squared over 2 plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus dot dot dot. So if we want the expansion of e to the x squared, we just have to plug in an x squared everywhere here. So we'll get 1 plus x squared plus x squared squared, which is x to the 4th over 2, plus x squared cubed, which is x to the 6th over 3 factorial, plus x to the 8th over 4 factorial, dot dot dot. Alright, so now we're ready to write out what this is. Here in the numerator, we're going to have e to the x squared, that's this expansion, minus x squared minus 1. So these two terms are actually going to cancel out. So we end up with just x to the 4th over 2 plus x to the 6th over 3 factorial. Let me just write out what that is. 3 factorial is 6, and x to the 8th over 4 factorial, which is 24, and it keeps going. And cosine x minus 1, well, that's just going to be cosine x without this first term that's going to cancel out. So we'll end up with negative x squared over 2 plus x to the 4th over 4 factorial, which is 24, minus x to the 6th over 6 factorial, which is 720. Okay, and then we're going to divide this whole thing by x to the k. Now if we look at this, what we see is that when we multiply these two polynomials in the numerator, this is going to be plus dot dot dot, then our leading term is going to have x to the 6th. We're going to take this x to the 4th and this x squared, multiply them together, we'll have negative x to the 6th over 4. And then the rest of the terms are going to be higher powers, like you'll have x to the 8th power, and you can get plus the x to the 8th, whose coefficient is going to be, let's see, if you take x to the 4th and x to the 4th, so it'll be 1 over 48, and 1/6 minus 1/2, so that's going to be minus 112. Okay, and it'll keep going this way. But the important thing is to look at is that this leading term, this negative x to the 6th over 4, because when you divide this whole thing by x to the 6th and take the limit as x goes to 0, then, it's supposed to be x to the k. Then if k is less than 6, then x to the k is just going to cancel out, and like if x, let's say k was 5, so then the x to the 5th is just going to cancel out of all the terms from the numerator, and you're going to end up with a leading term of x, negative x over 4, and as you take the limit as x goes to 0, then well, all these terms are just going to zero out. So that's no good, because we're told that the limit is finite and non-zero. And if we take k that's bigger than 6, like 7, then the x to the 6 is going to cancel out, and we'll have 1x left over in the denominator, which means that when x goes to 0, then we're going to have an infinite limit. So that's no good either, because we want it to be finite, like it says in the problem, finite and non-zero. So the only choice is that that k is equal to 6, and then the x to the 6 will cancel out with x to the 6 in the numerator, and we'll have something like negative 1/4 plus something times x to the 6 squared plus something else times some other x to the power, and then when we take the limit as x goes to 0, all those x's are going to drop out, and all that's left is negative 1/4. So our answer is that k has to be equal to 6, which is either choice B or choice D. And we see now that the limit, when k does equal 6, is going to be negative 1/4. So our answer is D.